Okay? After we got the data from the tachometer, we write a code to load the data, and then we need to use a sign fit to take this data and looks of the purpose of this function. Let me show you. In this website you can access this code from this website. The TA is gonna tell you if you don't find it. Okay, sign fix, we use sign fix because we need to fit the waveform, right? It's okay to look pretty, and it takes 4 parameters. The first one is the transpose data. The second one is the period, and the third parameter is the time, right?
Start time.
The start time, and the last one, the fourth parameter, is the sampling time. And
what it gives you back is the A hat, theta, omega, and RMS, which is your amplitude of the sine wave, the phase, the frequency, and the RMS value. Then you use that in the next line, line number 12, to get the frequency response, which is gain times e to the I theta. Gain is A hat divided by your input amplitude, and theta is nothing but the phase that you got from sine fit. And that you store for each and every element in the loop. Like, so you'll have 3 amplitudes and 15 frequencies each, so it'll be a 3 by 15 matrix or 15 by 3 matrix, which contains all your frequency responses.
Exactly, those are right here, because you have to, you have to write on a for loop with 15 elements, and you save for each frequency response, for each amplitude you save what is it?
The frequency response.
Yeah. Okay. After that, because the purpose of this lab is to compare the calculator and the measure frequency response. So in order to get the frequency response of the motor, we need to use this formula, this function FRD. It returns the frequency response of every amplitude. For example, for the first one is 0.2 volts. This amplitude is going to return the frequency response, and so on. After that, we want to calculate the transfer function of the system, and we need to use the
inverse frequencies.
And it will return the numerator and denominator for the transfer function for each frequency response, for each amplitude. After that, we just use TF to get the transfer function, and let me run the program using the measure system and the calculator system, because I want to compare those two. In this simulation, I'm going to simulate the body plot, the nice squid, and the Nichols chart. So let me see. It doesn't have the grid on. Grid on?
Yeah, we can put the grid on after you finish.
Yep.
So, can you put the grid on now manually?
Yep. Like that. This is the body plot, this is the Nyquist chart, and this is the Nicholas chart, and this is the Nyquist diagram. So let me listen. Yeah, for this. see. Yep, looks better
Okay.
like that.
So that was Lab 0, and you got your K and tau for the transfer function for the motor, and you also got these nice plots for Nichols, Nyquist and Bode plots for the system, which is the objective of the lab. And so that's it. Our lab is done. Thank you very much.
Thank you.